In this video, the same drill as usual. A new toy will help us to identify the geometry, and then some less new toys will try to reproduce those geometries. Alert! Sketchy things ahead. This is the drill press my grandfather made like 30 years ago. I think it deserves a bit of care. There is one feature to be added and one to be fixed. First of all, right now it works. I'll show you. Oh, you see, it works. But check out what is going on right there. This pulley part says in its own language, "I'm tired, boss." It wanted to pass away years ago, but we have fixed it temporarily with screws. And it didn't survive on its journey even right now, but the time for relief has come. There is also this 3-phase motor switch with overload protection. I would like to put here in a small VFD instead for smooth RPM control. It is powered with 1-phase 230 volts AC. I think it would fit right here just perfectly, making sure there won't be no collision with the handle mechanism. We will gain forward and backward motion too. Let's take a look at the exhausted pulley. It was made out of textilite, with a brass sleeve inside. It's quite light, and I would say it's not as tough, but actually considering it was there for so long, it was tough. But the time has come. 16mm shaft on the motor, 5mm key. Now the motor specs. 750 watts power, 3-phase, 380 volt AC, triangle connection, 1400 RPM at nominal. Belt tension. This is something I would like to improve a little bit. High and medium gears tension is quite okay. The low RPM gear is a bit loose. Maybe we will be able to correct it a little bit. A-type V-belt. Alright, let's do it. Oh wait, today we will have the opportunity to test a new tool. Revopoint sent me this MetroY Pro 3D scanner to check whether it is useful in a home workshop. Well, I think it would help me already a lot in the past with some projects, especially when I was doing my milling machine CNC conversion. This time, however, I'm going to give it a try on something a bit easier. My drill press would love to have a new V-belt pulley and the VFD installed. Actually, the things I'm going to do today would be possible to do without the scanner, but this is going to be a nice scanning training session for me. About the scanner, in simple words, it's a tool which delivers the possibility to digitize more or less complicated 3D objects. It's got a lot of features, high accuracy, many scanning modes, etc. Everything for different scenarios. If someone is interested in details, I'll leave a link in the description. There is also a dual-axis turntable for rotational scanning and a mobile kit. Thanks to it, it is possible to use it through Wi-Fi in your home. Important! The scanning software is free, but it requires quite a good PC. Alright, let's plug it in and check out what it can do. Let's start with the V-belt pulley. I'm going to give it a try with the turntable. There is the tilt adjustment. Alright, that might be helpful in some cases. I think we should perform a test scan first. It seems to work. Okay, enough of this. Let's get serious. Depending on the parts we would like to scan, there might be needed markers. Let's spin and try to download some pointy clouds. It seems to work quite nicely, but the laser line doesn't fit into the deep grooves yet. Luckily, we can perform more scans and fuse them together later. First scan performed. Now the second side. I performed also 2 additional scans in crossline mode in order to catch more details of the grooves, to make sure the lasers are going inside the grooves. After scanning, there is some post-processing to be done, like removing the unnecessary details, surface smoothing, and so on. Next, merging the scan attempts. Usually, merging can be done automatically. Some finishing touches and the STL file is ready. Depending on how good accuracy we expect, the post-processing can be really fast or need a bit of care. Right now I have the 3D scan, which is my template for further CAD designing in ZW3D. Using it, I can make my own part design on the scan basis. I'm going to improve it a bit though, according to the metal piece I prepared, the tools I have and my thoughts I have in mind. Speaking of the metal piece, I've got a structural steel round bar, about 70 mm long. The outside diameter is 160 mm. It's the same I would like to have it when it's finished. Hopefully it will be enough. I can't fit a bigger one into my truck. Seeing how much I had to take off to make it clean, I am a bit worried. At least I have enough stock in regards of thickness. Hopefully. Clean it up. Now with the same tool I'm going to rough out the specific pulley diameters. Alright, well, that's a mess. And we are not quite there yet. But no time to waste. To make the grooves, I'm going to use this tool.
Whoops.
New tool, new mindset, new horizons. For the grooves, I made a CNC path using the W3D CAM module. After a quick solid verification, seems about right. Fingers crossed. It doesn't sound nice. I dislike those high frequency sounds, but it seems to do the job. I guess the cutting tool vibrates cause it's a bit thin. Maybe they knew what they were doing when making it? Maybe I shouldn't have improved it? Nah, I'm on the right way, I think. Quick test fit. Sweet. The second groove will be just an offset of the first cycle, but with small fits and speed adjustments. The last V-belt groove has to be sadly made after a flip round. Let's take the thickness to dimension first though. And the last groove. Nice. And now the inside hole. My drilling setup is still quite sketchy, but I guess it should work. And during the final steps, I realized I won't be able to dive in with my ID cutting bar. The only way to make a 16mm inside hole was to do it with a drill bit, right to size. All I can do right now with my tool base is to pray and drill away. The next thing was the QA. Gonna rough it out first on the mill. What the f***? Alright. Alright. The rest is going to be machined down with bare hands. Well, not great, not terrible. I think it came out not bad. It's got some war scars, especially from when it hit the ground in between operations. But overall, it looks like it should do the job. Oof, I thought there would be run out after the inside hole drilling, but it seems fine. Lucky me. Don't do that at home. Let's check for belt tension. Not bad. Not bad. Could be better. That's caused by the too small stock. About 2mm on the diameter made the unfortunate difference. Now the VFD. Black or shiny objects are overall difficult to scan. Let's see if the scanner will do it. This time I used the crossline mode. It should do well with glossy and black surfaces. Yep, it catches a lot of details quite efficiently. Now the backside. I have to admit, it's quite fun to do. All the blue lasers around. Now same history as with the Pulley, post-processing. This time I had to align it manually though. It's not difficult, but it takes a bit more time. And we have the mesh ready. In ZW3D I made the VFD mount according to earlier measured sizes. I regret I couldn't 3D scan the whole drill press, but I wasn't able to take my PC to my workshop those days. The laser has to be at least in the same Wi-Fi as the PC we are using, and my PC wasn't there. I inserted the 3D scanned VFD model to check if the dimensions are okay and everything fits fine. Let's print the mount. I used PETG filament. Five and a half hours and the print is ready. Almost. Awesome. It's going to fit nicely on the drill press. Now I'm going to act like I know something about electrical stuff. Or something. Wiring of this little guy according to the symbols on its back. Live, neutral and the protection nerve in the power supply section. This 3-phase AC motor was designed to be used in a triangle connection. Somebody who wired it like 30 years ago did the star connection here, so it generated about 3 times less power than it should. Initially I thought that I will gain power and smoothness when I switch to triangle connection, but I will gain only smoothness. That's because I will wire it in triangle, but when I was planning all of this, I thought that the VFD was powered with 380 volts. I was sure, and somehow it happened to be 231 phase. So sadly, we will stay with about the same power as until now. But maybe in the future, if it lacks power, we will have some room to improve. Okay, job's done. Looks fancy. Let's test it. Oh, and by the way, thanks to the VFD I can generate on each pulley about 50% more speed. I set the max frequency to 75 Hz instead of 50. Over the 50 Hz mark it might lose a bit of torque, but more speed on each gear might be handy for some scenarios. The torque on low RPM is not that bad for a not even half-powered 750 watt AC motor. Wait a moment. And the best thing is, it still drills after these modifications. That's something I didn't expect to happen. Today's adventure has come to the end. My drill press got cured out of one injury today, and its back shines a little bit more. The VFD will add some smoothness for my future jobs. Oh, and I enjoyed the first tries of 3D scanning too. It's a nice tool to have at home. I see the use of it in making things which broke and are difficult to buy, like old car parts or old machine parts. You know the drill. It's getting especially easy when you can just 3D scan something and directly send it to a 3D printer if it's something that you can make out of plastic. You're getting STL files right after post-processing your 3D scan. The scanning software is free, but Revopoint has its own designing and measuring software available too, but that's something that you have to pay additionally. But if you have your own CAD software, you will probably be able to use it too. Like me, I used ZW3D and it did the work just fine. If you're interested in such 3D scanner, I will leave a link with the details below in the description. Have a nice day and thanks for watching.